So now we are in unit 13.5, and in this we discuss the properties of monosaccharides and then disaccharides and polysaccharides. So we start with discussing the properties, chemical properties of monosaccharides. Again, in this unit we are going to identify the products of oxidation or reduction of monosaccharides, determine whether a carbohydrate is a reducing sugar. So, and this we will discuss briefly, but this is an alcohol of the sugar. So, and this is what we use in sugar-free gum. So you can see it is alpha, the sorbitol is what we are using, but we'll discuss this briefly, and in a short minute we'll discuss what that is. So we start with oxidation of monosaccharides. Remember, we are discussing chemical properties. So oxidation of monosaccharides. What is oxidation? Oxidation is addition of oxygen or loss of hydrogen. So monosaccharides in solution, they have small amounts of the open chain form present. If you remember, we were discussing the mutarotation of the cyclic structure. So when a monosaccharide is in solution, there is a trace of the open chain present. So in a monosaccharide with an aldehyde group, glucose, with an aldehyde group in the open form and a hydroxyl group adjacent to the carbonyl group, you can oxidize that molecule. Oxidation, addition of oxygen, acid. So this functional group, C double bond OH, is an acid functional group. So glucose, gluconic acid, can be oxidized to carboxylic acid by an oxidizing agent such as Benedict's reagent. So oxidizing agent is an agent that can induce oxidation. So Benedict's reagent is an oxidizing agent which is helping introduce oxygen into the glucose molecule. So again, a monosaccharide, we said that they're mostly present in cyclic form because cyclic forms are more stable. But when you have a monosaccharide in solution, it undergoes, the molecule undergoes mutarotation from the alpha to the beta isomer, leaving a trace of the open molecule, open chain structure, which has the aldehyde group which can be oxidized to an acid group in the presence of an oxidizing agent, which is Benedict's solution. And here you can see that this is the copper ion present in a Benedict solution, which helps in the oxidation of glucose. Now sugar acids, again we said, we are repeating what we just said, are produced from the oxidation of the aldehyde form with Benedict solution. This ion is present in Benedict solution. You can see copper 2+ ion is reduced to copper 1. And how does that happen? By taking in an electron. You can see there is a 2 positive charge and there is a 1 positive charge. There is a reduction in a positive charge. And that is possible by taking in electrons, and taking in electrons is reduction. So these sugar acids are named by replacing the OSE ending in the monosaccharide by the onic acid. We saw glucose, gluconic acid. So a carbohydrate that reduces another substance is called a reducing sugar, because this glucose solution is able to reduce copper ion with 2 positive to copper ion with 1 positive. That is reduction. So because the sugar is able to do that, it's called a reducing sugar. It has the ability to reduce the other molecule, reducing sugar. Now fructose, oxidation of fructose. Now fructose is a ketohexose. It contains a ketone group. Remember, the second carbon is the carbonyl in fructose, which usually can't be oxidized. But what happens in fructose is there is a rearrangement in solution when fructose, a ketohexose, rearranges to form glucose and is then oxidized in Benedict solution. So you see this is a fructose molecule with the carbonyl on carbon number 2. It undergoes rearrangement into a glucose structure with the aldehyde in carbon 1, and this open structure will then undergo oxidation in Benedict solution, reducing copper 2 positive to copper 1 positive, again acting as a reducing sugar. Reduction of monosaccharides. This is the next chemical property we're discussing is reduction. What we discussed previously was oxidation, which was addition of oxygen. Here we are discussing reduction. Reduction, again, by definition, is addition of hydrogen or loss of oxygen. So here we can see, we'll find out what's going on. Are we taking away oxygen or are we adding hydrogen? We'll find out. So the reduction of the carbonyl group in monosaccharides produces sugar alcohols. Here we are adding a hydrogen. We can see we are adding 1 hydrogen here. So that's the reduction. So now by adding hydrogen, we are creating an alcohol group. So produces sugar alcohols, which are also called alditols. So now glucose, sorbitol, and this is what we had started off, the chemical properties with sorbitol. So this is what is used in sugar-free gum. So converts D-glucose to sugar alcohol D-sorbitol. So in the presence of a catalyst, you are adding hydrogen, and addition of hydrogen is reduction. So that's what we're discussing, reduction of monosaccharides, and reduction produces sugar alcohols. Alcohol, the OH group here. Aldehyde reducing to alcohol, that's where the reduction is. Sugar alcohols are named by replacing OSE ending of the monosaccharide with ITOL. Glucose, sucrose, mannose, sorbitol, xylitol, xylose, mannitol, mannose. These are different examples. You can see xylose, xylitol, mannose. So you're changing the name by replacing the last 3 with these letters. They are used as sweeteners in many sugar-free products such as diet drinks and sugarless gum. So by reducing the sugars and adding hydrogen, they are being used as sugar-free substitutes. So that is the very important use of those reduced sugars. Write the product of the reduction of D-mannose. So this is our aldehyde. So we have to add a hydrogen, mannitol. So we are adding hydrogen, D-mannitol, reduction, addition of hydrogen. Normally, this is again glucose testing, again glucose. Normally, blood glucose flows through kidneys and is reabsorbed into the bloodstream in the kidneys. When the blood level exceeds 160 milligrams of glucose, the kidneys cannot reabsorb all of the glucose, and it spills over into the urine and causes a condition, glucosuria. Oops. Now this is again extension of what we were discussing. A symptom of diabetes is a high level of glucose in the urine, which can be identified using Benedict's test. So the colors of the Benedict solution correspond to the presence of glucose in urine. Brick red, there is 2,000 milligrams per deciliter, 1,000 milligrams when it's yellow, 500 to 50, 0. These are important values for an initial test, initial urine test for blood glucose. So a symptom of diabetes mellitus is a high level of glucose in the urine. Again, we can go back and see that when the blood level exceeds about 160 milligrams of glucose per deciliter, of the kidney cannot reabsorb all of the glucose and it spills over into the urine. And that's what we are discussing here, is the presence of glucose in urine because of the inability of the kidney to absorb all the glucose. So these are the different colors, and this is how the very initial test of diabetes happens.